and I'll just pause it for now.
Excited to be back. Very excited to be back here. I'm Keely Mackmer-Wessels. I would call myself a math coach. I am in Porto right now. So I've been in New Zealand since 2020, and I still do a lot of my work supporting Oakland Unified School District in California. So we are going to jump into it. I do have 2 links that I'm going to share in chat. I'm hoping you can go ahead and open these links up. One is just like a packet with some information that you might want to come back to later, less important for the session right now. And the second link is to a Desmos activity, and I'm hoping you can jump into that. You don't need to sign in. If it says like sign in, it just says join without signing in is totally fine. And you should get a screen that, let's see. So once you click that link to join Desmos, you should get a screen that looks like this. Awesome, I see some people are popping in, good work. And just a little check-in to get our session going. How are we feeling coming in here? Are we energetic? Are we feeling positive? Are we feeling negative? You can just drag that battery on your screen around to share how are you feeling coming in to this session. Let's give people a moment to open up that link. We've got about, awesome, we got 8 people in so far into the Desmos. Cool. So I have it on anonymous, but here's what I'm seeing. We're mostly feeling positive. Some are a little bit more energetic than others. Some feeling a little bit tired, but looking forward to the session. So awesome. So kind of there's where this group is at. It's feeling pretty positive, which is a good start to the session. I like it. I at least see a few smiles as we're looking at this. It's kind of fun to see. Awesome. So I'm going to jump back. So yeah, sorry if you didn't come over to your Zoom screen so you can see what everyone's putting on there. Once you've done that in Desmos, you can kind of check out what other people are putting. And we are going to continue on. So I'll flip back to my slides, but feel free to continue to add anything in Desmos. And here is my plan for, this morning is we're going to jump in and experience a math language routine called Co-Craft Questions. And then we're going to talk a little bit more about what math language routines are. Then we're going to try out another math language routine together and then kind of talk about how this might make sense in your own practice. And the goal really for today is to understand the purpose and power of the math language routines for providing access to both mathematics and language and for really amplifying student thinking. That's what we're hoping to get out of the next 40 minutes. So I'm going to ask us to jump right in and put on our student learner lens. I'm going to ask you to think as students for just a moment and engage in this task as a primary school student might, and then we will go back and debrief it as our educator lens adults. Okay. So here is what we are going to look at. We are going to think about shark teeth, because who doesn't want to think about shark teeth? So what I know is that the average teeth of an adult human are about 1.5 centimeters long, and the average teeth of a great white shark are 7.5 centimeters long. So I'm curious, with this information, what mathematical questions might we be able to ask? So I will ask you to, I'm going to invite you to go back over to your Desmos screen, and in Desmos, please share some mathematical questions you could ask about shark and human teeth. Okay, so we're going to take about 30 seconds of quiet think time. So in Desmos, you are trying to write some questions that you could ask about these human and these average adult human and great white shark teeth. So your Desmos, screen, go back. Yeah, so it should look like that. Okay, so I see lots of great questions coming in. We're going to move to a little conversation in breakout rooms. When you get there, you can say hi and where you're from. Should be groups of 3. And then take turns sharing the questions you came up with your small group. And you can add any additional questions that you can think of based on this situation. So I'll see you all back here in 3 minutes.
Oh, Keely, oh yeah, no, that's all good.
We've got one more coming in.
Yeah, no, we've got 3, 3, 3, 3. Oh yeah, we've got one more coming in. Josh coming in now, so maybe we'll just pop him in. We've got 5. Oh, here we go. We'll put him into room 1, shall I?
Sounds good. We might need to give them, hi, welcome.
Hi, Mel.
You know what? We should make sure we give them the links though.
Oh yes, here we go. The links to Desmos or the doc?
The Desmos one is the most important one for now.
Right, I'll pop that in now, broadcast the message. Oh, I can broadcast the voice now.
You can.
I didn't know. That's new, isn't it?
Yes.
Should we do that? Hi, Robin here. Just letting you know I've dropped the link to the Desmos into the chat so that you can actually get access to that. Oop. Hang on, it looks like. Ah, here we go.
Hey, welcome. Did you get kicked out? Are you okay?
Here we go. I'll just see if I can sort this other lady out who's busy texting me. She's obviously given me a wrong email address, I suspect. Send. They're very cool little Desmos things. I love Desmos. And Emma, where can we pop you? Mel,
I think they're coming back in about 12 seconds. I think we just pause.
Oh, okay. Mel might have popped away.
Yeah.
Anna, have you did you drop off? Oh, here we go. Yeah, should we close?
Yeah, I'm here, but I think I'm in the wrong session.
Oh no.
What session are you wanting to be in?
Secondary session. It's the secondary session.
It's connected.
You want to be I'll send you another email. Go in and join. You want to be in Tim Erickson's session.
Oh, am I in the intermediate session? And I would like to go to 11 to 13 year levels.
Right, I'll put you in Tim's session. Oh, you'll have to join. No, I think did I have to send you an email this morning?
Yeah,
I think it back.
I think it was a wrong email, a wrong link.
Right.
Awesome, Robin. I'm going to keep going. Okay.
You keep going.
You
just leave Anna, and I'll send you another email.
Okay, welcome back, everyone. Really interesting to see some of the questions you wrote about these shark and human teeth. So kind of got some questions about thinking about like what the shape of these teeth might be, how much longer is the shark teeth than human teeth, right? Right, smaller or bigger, like how does it affect the rate of food consumption? That would be interesting to explore, right? So several different ideas of questions we could ask here, right? And then a few more that I want to look at. Some people were thinking about the size of the teeth, right? That idea of how many human teeth make up one shark tooth, or how many human teeth could be lined next to a great white shark tooth. I love that these two questions came from people in different rooms. And you know what? I like these questions so much. I think we're just gonna, this is gonna be the math we're gonna do today. We're gonna think about this question that you just asked. Okay, on that note, I'm gonna pause on us being in student mode, but this is the moment where students would come up with questions on their own. And what's amazing here is as we look at the questions that I'm sharing on my screen that I took from what people were putting into Desmos, I can go back over to my slides, and if I look at the next one, this is actually the task that I found when I went to NZ Maths. I just went to NZ Maths and looked at the rich learning activities and looked at level 2 and clicked on the first one. And the question they're asking is how many adult teeth stacked end to end would be needed to make the same length as the great white shark's tooth, which is essentially what many people were asking already when I asked you to ask the questions yourself. So that was an example of a co-craft questions, right? And in this case, because the questions, I had some questions amongst the group that were really the same idea of what was being asked, that really getting at that same achievement objective, I would just be like, hey, we're going to do the question so-and-so asked today. I love it. Let's do that math. To really give the students more ownership of what's happening in class where they got a chance to ask that question. So this is really the purpose of the co-craft question. So take a moment to read over that. So sometimes we have situations where students look at the numbers in a problem and don't always read it and just want to like start doing something with the numbers, right? Without really thinking about what the math is. So the co-craft questions really slows things down because there's no question to answer. They have to think and come up with a question themselves and think about how can I word a mathematical question? How can I word some of the ideas of even rate of food consumption, thinking about if I gathered some more information, what sorts of questions could I answer? Asking about the shape, right? Just thinking about all these different mathematical questions that could be asked about that context. So that giving students to get inside that context before feeling pressure to produce an answer, right? There was no answer you could produce there. You were trying to ask a question. So this is really used to like launch a task, right? To kind of slow down, launch the task together, get everyone into the context before we work on that math. And here are the steps for this math language routine. And this is also in that participant packet. I copied this slide in there so you have it. That you present a situation just like I presented about the sharks, right? Students write their own mathematical questions that might be answered about that situation. They get a chance to compare questions with a partner or partners. Students share out and then reveal the questions that we're going to work on today. And that whole reveal the questions that we're going to work on today, it could be the ones that as a teacher you have planned, or it could be, hey, that one the student asked is right exactly what we want to work on. So we're just going to answer that student's question. That's going to be the math we're going to do today. So thank you everyone for participating as a student in that one. And I'm going to talk a little bit more then about math language routines more generally. So we just experienced a math language routine called co-craft questions. And I'm curious, like, FIST to 5, with FIST being I've never heard of math language routines before, and 5 being I use these in my practice all the time. Can you either show me in the window or you can put into chat, like, how familiar from 0 to 5 are you with math language routines? Okay, I'm getting some zeros. Cool, well, something new, awesome. I'm glad I can bring something different. Yeah, I'm getting some zeros in chat too. Okay, cool. So we will talk more about those then and what these are. So you got to see one. I kind of wanted to try one out before I said, here's what these things are. Starting with just thinking about what instructional routines are. When I talk about an instructional routine, I'm thinking about something something that is not like a management routine, like how students enter your class or how you pass out paper, but it's a routine that's really focused on instruction and is like a series of teacher and student moves that really support mathematical learning and sense making. You may have heard of a which one doesn't belong, or doing think, pair, share, or notice and wonder, or a number talk. Those are all examples of instructional routines, right? And those all, the reason we might use these are really to provide that predictable structure for both teachers and students, right? Easier for students to focus on what they're learning since they know the expectations for how they're learning, right? Creating a safer learning environment. It also allows teachers to focus on really listening to student thinking since they are using this familiar structure of the routine for how they're facilitating a class. And they really push on who's doing the math in math class, right? Promoting student discussion and engagement. You know, with the one we just tried from the start, they're asked to be engaged in the math. They're asked to come up with the questions. So that's a little bit about instructional routines more broadly. And then, this session is about a specific type of instructional routine, this like subset, if you will, of instructional routines called the math language routines. These came out of Understanding Language project out of Stanford University a few years ago. And I've talked, I think, in last fall about a couple of other routines from this list. I think we did Stronger and Clear and 3 reads. And so I came back to talk about some different ones with co-craft questions and critique, correct, and clarify. So these language routines are really emphasizing that relationship between learning math and learning language, and really pushing on like language functions, what we want students to do with language as they engage with the content and interact with others, right? Are we asking them to explain or justify or classify, right? And just thinking about how we're asking students to use language within math class. So math language routine is really just referring to like a structured but adaptable format for amplifying, assessing, and developing students' language. The routines emphasize the use of language that is meaningful and purposeful, and these routines can be adapted to fit different mathematical content and context in both primary and secondary classes. And if you want to read more about these at all, in the participant packet that you should have the link to, there's the list of the 8, and here's the 2 we're talking about today, what their purposes are, but then this link will take you to a document that says more about this work. And again, kind of thinking about, at some point we thought about that relationship between math content and language really being limited to like vocabulary. Students need to know what an isosceles triangle is or something like that, right? But a newer way of thinking of things is that there's a much bigger overlap between the content and the language, right? That we use language within math class for a disciplinary purpose, right? Those functions in math class. That students really, you know, they express their sense making through language. And the math language routines that we're talking about today really support students in making meaning through language. Okay, so we are going to jump into our second math language routine for today called Critique, Correct, and Clarify. And this is the task. So take a moment and read this over. And we are going to pretend for a moment that this was a problem that we have already worked on together, right? So I'm going to ask you to jump back into being a student learner mode. And you can be a little bit older this time, maybe like a year 7 working on this problem. But I want you to think as a student learner might think about this problem. And we're going to pretend that we worked on this problem, let's say yesterday, and I'm coming back to it. Okay. So I'm going to invite you again to go back over to your Desmos screen. And the task is there. And on your Desmos screen, you will also see this sample student response. So this is what one student wrote, okay? So I'll say this is a student in my other class actually answered the problem yesterday this way. They said that mixing 8 milliliters of blue water with 13 milliliters of red water would result in the same shade of purple because I added 10 milliliters of each color. So that is what a student responded to yesterday when we were working on this. And we are going to do a critique, correct, and clarify right now, thinking about this student's work. So in Desmos, I want you to think about, hey, what makes sense here? What's smart here? And also think about what changes you would suggest for this student. So we will again take 1 minute of quiet think time, and do give a shout if you need that link back into the Desmos. But we're gonna take 1 minute of quiet think time in Desmos, and you should be working on answering those 2 questions. And if you need to, let's see, if you need to, you should be able to move over to the next screen if you're not there in Desmos. Let's see. If you go up in this corner, you should be able to move to the next screen, where it says like screen 4 of 7, should get you to the screen that we're all on, where you can answer those 2 questions about this student's work. Awesome. Okay, I see lots of great stuff coming in. Here's a few of the responses I was seeing about why did the student write this? Could one of these 4 people say a little bit more? Is someone here brave enough to unmute here and just share a little bit more? If you see your response up there and can say a little bit more about what you saw, that they're like, oh, I can see what the student was thinking there.
Hi, Phyllis. How are you?
Welcome.
I teach at the Northern Health School, so I don't have a regular class. So I'm trying to remember my maths teaching. Is it because we've taught them that with the equal sign in the middle, you do the same thing to one side as to the other, then that's their knowledge that they're bringing to this?
Yeah, that sounds good, right? They kind of like did the same thing to both sides, right? They added 10 to the red and 10 to the blue. Like there's some thinking here. Awesome. Thank you so much for sharing. Okay, so let's then think about what we might want to change. What we might want to change about this. I'm just going to share a few ideas. And let's see. Here we go. So here's a few ideas that people put out there of what changes they would suggest to this student. So if you see your work up here and you're willing to unmute and just share a little bit more, I'd really appreciate that.
If nobody else wants to, I can jump in there. So basically, since we looked at, because they added 10 mils to each side, but it doesn't, as a few of the others also say, it doesn't actually stick to the ratio that they've got going on there. So although like you can understand where the student would have got the idea from, it's not quite sticking to the ratio. So maybe as a teacher, I'd want to like go back and revisit ratios with them and kind of go over what a ratio is and different ways that we can use ratios.
Okay, so they didn't, so when they added the same thing to both sides, they didn't stick with the ratio. Okay.
Yeah.
Can someone else add on of how can they stick with the same ratio? What could they do? How could they shift their thinking so they're sticking with that same ratio? Can I hear one more voice to add on to this thinking?
Yes, I think that someone said there to rather multiply the 3 and the 8 by the same number than adding to them, and then they'll be the same ratio. That makes sense.
Okay, so thinking about multiplying rather than adding here to keep that same ratio. Thank you. Okay, well, we've got some ideas now from this problem about what made sense about it, but then what changes we want to make. So I'm going to add on the next screen in Desmos. So on the next screen, I'm going to ask you to think about writing an improved response based on what we just talked about what made sense, what needs improvement. I'm going to ask you to write an improved response on the next screen. So you may need to go up into the corner of your Desmos and go to the next screen because I want you to be able to see your other answers, but you should, just going to get in students. If you go up here, you should just be able to hit the next on, and that'll get you to screen 5 to write an improved response. And I'm actually going to give you a few minutes in breakout rooms to talk to a few other people. Now that we've looked at this original student response, how can we improve it? So you're going to be in with a different breakout room, can say hi to those folks, and then work together to write an improved response. Also totally works if you just want to write one response all together and not all separately. That's great. Be fewer things for me to read anyway. But you're going to have 4 minutes in this breakout room, and your goals based on what we just learned. How would we write an improved response? You can type it in here. If it helps, feel free to, draw a picture or whatever in that box too. Okay. And I will see you all back in 4 minutes. But I do want to share a couple that groups came up with, right? So this group was thinking about keeping the ratios of the same color, right? So they did 16 and 6. And let's see, I think we had one other one. This group, let's see. This group gave us a drawing, right? To go with their thinking, right? Of showing exactly what people were talking about before when we were correcting that other response, was thinking about, hey, let's think multiplicatively, right? Rather than additively here, right? And doubling each of those, like they doubled the lengths of these rectangles. So thank you so much for those. So I'm gonna pause on us being in our student learner lenses and then think back more as teachers now. So I appreciate everyone engaging in those as students might. And just as someone said before about this, about the work, right? Here's kind of the purpose of this, right? Of this routine that we just went through. Right? Giving students a chance to really look at some work that may or may not be their own and may or may not be the same mistake that they've been thinking of, right? This is a chance to really re-engage in that thinking, and instead of, continuing to make the same, instead of trying to make the same mistake again, they are kind of thinking about, hey, where's that error happening and how do I do something different? Yeah, doubling the rectangle would change the area, right? But I think they were thinking in terms of the mixture, right? That if we double the amounts of each of those colors, they'll get the same shade of purple. But you're right, there's something there about area versus side length in there as well. So this is a routine that I would frequently use, like if I'd given an exit ticket one day and I was like, hey, like I got several students making the same mistake, that I kind of would just like combine them into one student answer and then share it back with the class the next day to go through this routine to really think of and unpack and make sense of, hey, there's some good thinking here. They're thinking about something that makes sense. And then what's the correction we want to make, and then a chance to really revise that. So here are the steps in a critique, correct, clarify, this type of like an error analysis, right? And I frequently will like claim it's not from this class, of like, it's a student in my other class. And a lot of times it would usually be like several of my students combined thinking that I see the error to then have us analyze. And it's really important to start with that acknowledgement of what makes sense. Like, why was there some good thinking here? Why does it make sense that the student wrote this? and then think of, hey, what do we want to fix, both in terms of the language as well as the mathematics. How can we maybe describe it better, right? And write a more complete answer, as well as fix any errors there might be. So those are kind of the steps in this routine. And give you a moment to read over the purpose of the routine. Oops, I think I did that one already. My bad. Got there already. Sweet. So we are coming to kind of closing out our work here today. We got to experience these 2 math language routines, and now I want us to think a bit as teachers about how these routines impact student learning and when you might use them. So I have a few questions to think about, and we'll spend again a few minutes in breakout rooms discussing, and then we will come back together to close out. So I'm going to pace everyone to the screen that we should be on in Desmos, and again in your breakout room, you can say hi, and then I would recommend you pick one recorder, so only one person really needs to record in the Desmos. They can screen share if it helps, and we will spend, let's do 4 minutes discussing, so you can talk about whichever of these are most interesting to you in this moment, between the questions we have here. So you can either think about co-craft questions or critique, correct, clarify, or both, and just thinking about how does it support student access to language and or mathematics? How does it amplify student thinking? And when might you choose to use one of these? So again, we will spend 4 minutes in breakout rooms, and I will see you back here again after that. Really appreciate some of the things I am seeing here, right? I like that accessing students' prior knowledge as being something that really happens with some of these routines, right? They get to think about what they know already. They're not coming into a problem with nothing. They're coming in with their knowledge and thinking about what they bring to that, right? And yeah, opportunity to retrieve that. I like that, retrieve that mathematical language, right? They're encouraged to talk and write and think and have think about that mathematical language in order to write a question about shark teeth, right? How would you phrase, how do you start the question? What words do you use? What mathematical language do we need? How has my teacher written questions before? How do I write one that sounds like that, right? Yeah, high ceiling, low floor questions, right? There's a range of the questions that students are gonna ask, and they get better asking mathematical questions over time. Yep, and brings the context learning slowly, right? To help it make sense, right? Kind of given a chance to share ideas, gets more access to the language and the math, right? Yeah, so lots of good things in here. Just want to emphasize that in order for these to be routine, you got to try them more than once, because the first time it's a little bit of a fumble around of giving the directions and the math content. But as students get used to doing something, it's like, oh, we're going to co-craft questions. I know what that looks like. It means the teacher's not going to give me a question and I'm going to have to figure one out for this situation. So I'd encourage you to do that. And I think particularly with how math education in New Zealand is kind of making a shift around more students being able to explain, that it's important to think about how we're asking students to engage in these sorts of activities during their math classes. So I think, oh my gosh, there's so much stuff I want to look at here, but I'm glad people are seeing it as ways that you know, can amplify student thinking and give students chances to access math and language. So on that note, I am going to pause, since I know this is the end of my time. So thank you for joining today, and I will pass it back to Robin.